Okay, so let's practice these on exercise 6 here. So the first one, 12 raised to the negative 4 power. When I have a negative exponent, I need to put that thing in the bottom of the fraction, 1 over 12 to the 4th, and now that power is positive. Okay, we always want to keep positive exponents. That's a good thing here. Okay, so on the next one, this is basically all the multiplication property. So we get to just add up all these exponents. It's the same thing as w to the 5 plus negative 8 plus 6. So 5 minus 8 is negative 3 plus 6 is 3. So that's the same thing as w cubed. Okay, on number 3, it's the power property, so we have to give both the top and the bottom, multiply their powers times negative 2. So this is c to the negative 2nd power divided by d to the negative 4 times negative 2 is 8. The one that's in the top is negative, so it needs to come down to the bottom. So this will become 1 over c squared. The d to the 8th power is already positive, so it stays down there. D to the 8th. Okay, so there's the answer on that one. Okay, on number 4, here's the thing that a lot of students make a mistake on, and that is, well, you're learning about exponents and you're dividing, so you're supposed to subtract the exponents. So then they want to apply that same exact rule. I've got 20 divided by 4, and they want to subtract them and go, hey, that's 16. No. I have to divide those. That's just regular division. 4 goes into 20 5 times. Okay, and now along the way, I'm just going to subtract my exponent. So x to the, I got 2 minus the 4 gives me negative 2 power. Y raised to the negative 4 minus 1 is negative 5th power. And the z's, 5 minus 3 is squared. Okay, I don't want the negative power, so I'm going to have to write this. Everything that's positive stays up at the top, so 5z squared divided by, and then write all the negative ones down in the bottom, x squared y to the 5th. Okay, there we go. So on number 4, another thing that you can do is this. Wherever the exponents are larger, keep them where they are and then subtract the other ones from them. So for example, if I just look at, I'll switch colors here. If I just look at the x's, the power on the bottom is bigger, 4, than the top power of 2. So I can do 4 minus the 2, and it's to the 2nd power. Since 4 was bigger on the bottom, that's where we would keep it. Okay, same thing would happen on, say, the y's. The y's, the first power is bigger than the negative 4 power. So we're going to keep it on the bottom and then do 1 minus a negative 4, which is 5, y to the 5th. Okay, so there's another kind of shortcut that you could do if you notice those kind of things. Okay, so I will say this. Whenever you simplify an algebraic expression involving exponents, we want to keep them always positive. Look at the title here.
Always look on the bright side of life.
Okay, so if I have that expression that c to the negative n, it's not positive, we need to put it down in the bottom, so it becomes ab divided by n, or d times c to the n power. Okay, so negative exponents in the numerator need to come down to the denominator. Okay, so if I have this expression now where it's negative in the bottom, I have to keep the exponents positive. We're always looking on the bright side here. We've got to keep them positive, so that negative exponent needs to go back up to the top to make it positive again. Okay, so keep that in mind whenever you're simplifying these expressions, no matter how complicated they get. So here are some of them for you to try on 7a here. Simplify each one of these expressions. Pause the video. Alright, check your work here. On the first one, same base, add up all your exponents, you get x squared. On number 2, anything that has the same base, when we multiply them, we're going to add up our exponents. I did have a y to the negative 2nd power whenever I simplified that, so I need to bring that down to the bottom there to keep it positive. Okay, on number 2, power property, so each thing gets multiplied, each exponent in the inside gets multiplied times 2. So when I'm done, I get a t to the negative 8. It's negative on the bottom, so it needs to come back up to the top. So s squared times t to the 8th. Okay, on number 4, the way that I chose to do it is go ahead and apply the power property. So each one of the exponents on the inside got multiplied by 3, and then I simplified those expressions. Remember, a shortcut here is keep the exponent wherever it's bigger, so that's to the 12th power, and then subtract the 4th. 12 minus 9 equals the 3. Okay, and on the y's, the 18 is bigger, so 18 minus a negative 6 makes 24. Okay, I could have done it slightly differently. I could have taken this like so. I could have simplified what was inside the parentheses first. For example, x to the 4th divided by x to the 3rd is x to the 1st. Okay, and then the y's are bigger on the bottom, so that's the 6th. Y to the 6 minus a negative 2 is 8. All of this raised to the 3rd power, and then I could have gotten the same answer by multiplying the exponents on the inside by 3. Okay, so one more problem to wrap up this video, and then we'll look at some more stuff in the next one. Simplify this expression. It'll probably make you gasp. But go ahead. I want you to actually exhaust some of your brain power on this all by yourself. You might see something like this on your quiz, and I don't want you to, I want you to try it for yourself first. So pause the video, please, and then try that. All right, so how did that one treat you? Did it defeat you, or were you victorious here? Here's what answer you should have come up with: -2 m to the 5th divided by n to the 6th. Okay, so whenever you have a complicated expression like this, what I would suggest that you do is just multiply the fractions first to make it one complete fraction. So just top times top and bottom times bottom, simplifying the expressions on the top separately from the bottom. Okay, and then once I get it as a single expression, a division problem, now just apply the division rules. Now keep in mind, of course, that the first numbers, the coefficients there, are just regular division. 12 divided by -6 is -2. Okay, so don't confuse it with the division property of exponents. All right, on the m's, the 2 on the top is bigger than the -3, so we're going to keep them on the top. 2 minus a -3 is m to the 5th. The n powers, they're bigger on the bottom. 5 is bigger than the -1, so I'm going to keep it on the bottom. 5 minus a -1 is 6. Keep it on the bottom, and there you have the simplified expression. Okay.